In this video, we will learn how to draw mass shift graph and using that graph how to calculate Young's modulus of the material of the bar by non-uniform bending and optic lever scale and telescope method. So this is the experimental reading. So in this we have load and the telescope readings for loading and unloading. So the next column is mean. For every load we have loading and unloading. To get a mean of these scale readings, we have to add these two scale readings. 23.3 plus 23.5 is the mean of these two values is 23.4. In the same way, for all the values we have to take mean for the loading and unloading scale readings. This we have already done in a calculation method. The next is we have to take the load and the scale readings. For W, the mean value is 23.4 and for W plus 50 it is 27.3. So in the same way we have taken till W plus 350, the corresponding scale reading is 48.6. Next we need to find out the shift for every 50 grams. So to get the shift for 50 grams, 100 grams, 150 grams, 200 grams, what we have to do is we have to subtract the corresponding scale readings with the scale reading corresponding to dead weight. So for 50 grams of shift, we have to subtract 27.3 and 23.4. So for 50 grams, we got 3.9. For the next set of readings, that is for 100 grams, the shift is, the scale reading is 30.75 minus the dead weight is 23.4, we got 7.35. For 150 grams, to calculate the shift for 150 grams, what you have to do is subtract the scale reading 34.25 minus 23.4. So by calculating or by subtracting the 23.4, the scale reading corresponding to the dead weight with the other scale readings, we will get the shift for all the load 50, 100, 150 and 350. So with this set of readings, we have to draw the graph. First, let us take a graph sheet and split it into an x-axis and y-axis. So we have x-axis and y-axis. Then we have to take mass, which is 10 power minus 3 kg in x-axis, and the shift, which is 10 power minus 2 meters in the y-axis. Next, we have to choose a suitable scale. So on the x-axis, I am choosing 1 centimeter to be 50 grams, that is 50 into 10 power minus 3 kilogram. And on the y-axis, 1 centimeter is 2 centimeters, that is 2 into 10 power minus 2 meters. So see here on the x-axis, so every 1 centimeter it is 50, 100, 150, 200, 250, 300, 350. And in the y-axis, so I have started with 2, 4, 6 and I have taken till 26 centimeters, 26. Because my last reading is around 25, so I have taken it till 26. Next, what you have to do is we have to plot the scale readings corresponding to every weight. So for 50, I think it is around 3.9 and for 100 it is around 6.8 I think. So it is tabulated there with the help of those with the help of the tabular column. We have to plot this graph. If we plot it, we will get points like this. So you could see this trace of this points gives you a straight line. So connect these lines with the help of a scale from the origin. So we could see it is a straight line here. So one or two points may not join or fall on the straight line. Let's not bother about it. So connect it using a scale as a straight line. So if you connect, you will get it like this. So the next is we have to draw a slope for this. Don't take slope on the points which have already plotted. So let us choose 2 points other than the points we have already plotted. So I have taken a slope between 6 centimeters and 14.8, I think. I'm sorry, 15.8 centimeters. So we have drawn the slope now. Now let us calculate the value of slope. We know the formula for slope is equal to dy by dx. So on the y-axis we have shift s, and on the x-axis we have m. So dy by dx on the shift side, so y2 is 15.8 and y1 is 6, and the mass side it is 225 minus 85. And we have to include the powers also. This shift is in 10 power minus 2 meters and the mass is in 10 power minus 3. So 15.8 minus 6, we get 9.8 into 10 power minus 2, and 225 minus 85 will give you 140 into 10 power minus 3. So my S by M is 0.07 into 10 power 1. This 10 power minus 3, when it gets into the numerator, we get 10 power 1. So it is 0.07 into 10 power 1. Next, so from the graph we have got only S by M, and we need to find out what is M by S. So from the graph the slope is S by M equal to 0.07 into 10 power 1, and the M by S is nothing but it is the 1 by slope. So M by S is equal to 1 divided by 0.07 into 10 power 1 will give us 14.29 into 10 power minus 1. So this we have to make use during the calculation. So now let us calculate the Young's modulus using graphical method. These are the experimental readings we have already taken, and so we know G is equal to 9.8 meter per second square. The length L is equal to 10 power minus 2 meters, and D 90.5 into 10 power minus 2 meters. P is 4.6 into 10 power minus 2 meter. B is 2.668 into 10 power minus 2 meter. D 4.818 into 10 power minus 3 meter. M by S is 14.29 into 10 power minus 1 from the graph. And the formula for the Young's modulus calculation is Q is equal to mg L cube D divided by S 2p D cube. So yes, this is the formula. So we have got M by S from the graph. So I have taken separately and wrote it at the end. So Q is equal to G L cube D divided by 2p D cube into M by S. Now let us substitute all these values. So substituting 9.8 into 60 into 10 power minus 2 the whole cube into 90.5 into 10 power minus 2 into 14.29 into 10 to the power of minus 1, that is the M by S from the graph, divided by 2 into 4.6 into 10 power minus 2 into 2.668 into 10 power minus 2 into 4.818 into 10 power minus 3 the whole cube. Then now let us separate the numbers and the powers. First write all the numbers there, and separating the powers we have 10 power minus 6, 10 power minus 2 into 10 power minus 1 in the numerator, and in the denominator we have 10 power minus 2, 10 power minus 2 into 10 power minus 9. I have detailedly explained this calculation in the previous video. Then multiplying all the numbers in the numerator, we get 2737541016, and we have the powers there 10 power minus 6, 10 power minus 2, that is 10 power minus 8, and then you have another power 10 power minus 1. Then you have 2 into 4.6 into 2.668 into 4.818, the cube will give you 2745.20 into, computing all the powers, we will get 10 power minus 13. So minus 2 minus 2 minus 9 will give you 10 power minus 13. Then dividing the numerator with the denominator, we get 997210.0452 and into 10 power minus 8 into 10 power minus 1. The powers in the denominator, when it gets into the numerator, it is 10 power plus 13. So totally the overall power here is 997210.0452 into 10 power 4. So minus 8 minus 1 plus 13 will give you plus 4. And bringing the powers inside, writing it in terms of power, we have 0.9972 into 10 power 4. So pushing the decimal points, we get 10 power plus 6. So 10 power plus 4 and 10 power plus 6 will yield 10 power 10, which is the needed power for an Young's modulus. So we got Q equal to 0.9972 into 10 power 10 Newton per meter square. By the calculation method, which is already in the published video, we got 0.97 something. So by calculation and by the graphical method, we have the Q value to be 0.9.